Okay, so anywhere else on YouTube you can find the principle of the generation of electricity being either being the production and breaking down and reproduction of magnetic fields, either with the magnet where all the micromagnetic fields are in line already, or with chemical where the microparticles are breaking down and reforming, breaking down to produce the electricity that happens in between there. And but what I want to have on here is two principles of electronics that are not, I haven't seen enough, that are really critical to even having a chance at understanding computers and technology and all these things. One is the notion of the distribution of electricity using resistance to distribute and portion and direct electricity. Resistance is the tool that's used to direct electricity and portion it out to different parts of the circuitry. And this is, if you have a circuit here with no resistance, the wire itself is very little resistance, and you have another circuit here, if there's any kind of a resistance on one of them, all the electricity will flow to the, almost all it will flow to the wire for the circuit where there's no resistance. So if you want to have electricity flowing to more than one circuit, you have to have resistance on both circuits. So you need the resistance to portion out the electricity. If you want just a little bit of electricity to flow on this circuit relative to this one, then you have to have a lot of resistance relative to this one, just have a little bit of resistance. So then the second thing is the transistor and why it revolutionized electronics. And so this transistor, solid state transistor, has the material in the middle that is polarized to have, it has a high resistance. It's polarized against the flow of electricity passing through it. So this is the source of electricity. It's polarized against that flow, so it's such a high resistance that this electricity can't flow through there. But when you have another current, some electricity flowing through here, say even if it's a different power supply, it polarizes that material in the middle and makes it so it has very little, almost no resistance to electricity flowing all the way through it. So this is like a valve on a water valve, but this is the water flowing through the valve. But this is the same medium. The medium that turns it on is the same medium that flows through the valve. So what that means is that this medium coming out can now be used on any number of other valves. And the valve that turned this switch on could have come from any electricity from any other transistor or any combination of transistors. When you put these in combination, you could have any combination on or off that is required to turn this one transistor on or off, because the input and the output is the same medium, it's electricity. You can even have a circuit that bypasses this, so that if none of this is on, there's still electricity flowing out. And since all these go to the same ground, eventually, as long as they do all go to the same ground eventually, these all become, this becomes an output. Those become outputs. That potentially outputs into anything else in the system, any other transistors, any whatever. And this becomes then inputs. These are potentially coming from any, as long as this gets to a ground some way. That could be an output too. And you could have, and this could be then become the input. And this could be an input from anywhere else in the system, because it's electricity what goes in to power it. And this could be end up being an output too. So any parts of that, any relations you can imagine could be made just from the fact that the part that controls the valve is the medium that controls the valve is the same medium that it's controlled from. And then you also have that bypassing circuit, which gives the inverse condition. So the model that I never see is this simple little model right here, which shows you how a transistor works, is that there has to be a little circuit flowing through here, which allows the big circuit to flow through here.